So I'm going to continue with the questions. In the previous video I had just gone over this question which is here. So we'll continue with this one. For any two sets A and B, simplify. We have got A complement intersection B complement, and then we've got another complement outside. So the first thing that I'm going to do is I'm going to distribute this complement that is outside. So it will become A complement, there will be another complement. The sign here is going to change because I've distributed that complement, it becomes union. And then we're going to have A complement intersection B complement. Again, I'll distribute this complement to that part, so there will be two complements. When you have got two complements, they cancel themselves, so that will just be A union A complement intersection B. And then now I'll distribute the A union with the A complement, so that will be A union A complement, and then I'll get the sign that is on the mid, that's the intersection, and then I'll distribute the A union with the B, so that will be A union B. Now A union A complement, like if you get to the set A together with what is outside A, that is going to give you the universal set, and then intersection A union B. Now where does the universal set intersect with any set? It is that very same set. So the intersection of the universal set with any other set is that very same set. So the answer is A union B. We've simplified to the lowest level possible. And then given that A is negative 0 comma negative 5, and then B is from negative 2 to 2, C is from negative 3 to 2, find A intersection B. Now if you show this on a number line, the A itself has got elements 0 and 5. Now if you see A, these are elements, it's not a range. We've used curly brackets. Curly brackets, they mean elements, they don't mean range. So for the set A, I'm just going to put a dot here and also a dot here. This is A. I'll not join them because those are individual elements. And then I'll go to the set B, which is starting from negative 2 up to positive 2. This is the one now where we're going to connect them because it's a range. So that's the set B. Now we want where these two sets are intersecting. Where is A meeting with B? So you can see the only thing that is common between A and B is a what? Is a 0. 0 is in A, it is also in B. Well, 5 is not in B, so yeah, it's not part of the intersection. Therefore for this one, A intersection B is going to be just 0. It's an element, so you use curly brackets, it's not a range. So that is it. And then we go to A complement intersection B. Again, first I'll get A. A is 0 and 5. It has got these two elements, 0 and 5. Therefore when you are talking about A complement, it will be everything just except 0 and 5. That means we are going to have all the elements this side, but we are not including 0. That's why I'm putting an open circle there. And then we are going to continue with all the elements here, will not include 5. And then we are going to continue with all the elements this side. This is A complement. And then now the set B is just from negative 2 up to positive 2. So this is the set B. Now where are these two sets intersecting? A complement intersection B. Where are they intersecting? We can see they are intersecting on all these elements. All the elements which are here, they are intersecting, just except what? Except a 0, because it's not in A complement. So all the other elements is part of the intersection, just except a 0. Therefore A complement intersection B is going to be all the elements from here up to here, where we're not including 0 because it's not part of A complement. Then from 0 up to what? Up to 2. So this is the set that is showing A complement intersection B, that is negative 2 up to 0. We're including negative 2, but we are not including 0. And then we'll start again from 0. We're not including 0 up to what? Up to 2. Some of you might say, okay, since we are not including 0, why can't we just say negative 2 up to 0, not including 0. And then instead of me writing that from 0, I say I'm going to start from 1 and then to 2 since I'm including 1. Well, you not write this because before you come to 1, there are numbers which are greater than 0 before 1, like 0 0.5, 0 0.001, 0 0.002. So that's why you need just to write like this, because it's a range. And then let's look at B union C. So the set B is from -2 to +2, and then the set C is from -3 to +2. So we want to get their union. Union means combine these two sets, so we're going to combine them like that. So therefore A union C is going to be, it will start from -3 up to 2. -3 is not part of C, so it will not be part of the union, and 2 is not part of C, but it is part of B, so it will be part of the union. Union is different from intersection. If it was intersection, 2 wouldn't have been included because it's not appearing in both. But union just means combine. So 2 is appearing in B. So if we combine it to appear in the union. So that is it for this one. Let's look at this one. Given the sets A, B, and C, and the inverse set which is from -10 to 10, we want to find each of the following sets and represent them on a number line. The first one is A intersection B complement. So we'll start by putting first A on our set. Well, the first thing we need to put is the inverse set, that is from -10 to +10. And then we get our set A. The set A starting from -3 up to 2. We are not including -3, but we're including 2. And then we'll look at B complement. So if you check B, B is including 0 and 7. That means in the complement will not include 0 and 7. So 0 will be somewhere between -3 and 2, then somewhere 7 there. So since 7 is part of B, then it will not be part of the complement. And since 0 is part of B, it will not be part of the complement, because B is just from here up to here and we're including these. So for B complement we are going to go outside. Now we are going to go ending on up to where the inverse set ends. The inverse set ends up to 10, we are not including 10, and also up to -10, we are not including that also. Now this is B complement, also this is B complement. So where is B complement intersecting with A? So the common region is just this part. Therefore A intersection B complement is going to be -3 up to 0. So you can see that -3 is not part of the set A, so it will not be part of the intersection, and 0 is not part of B complement, so it will not be part of the intersection. So we're going to open like that, and I've shown on a number line. So this shaded region is the one showed on the number line. Remember the question is also saying show on a number line. Now the next one, we want to show A minus B minus C complement. We first simplify this set. This is the same as A minus what is inside. I can also write it as B intersection C complement. Remember there's another complement outside. And then this, okay, before I even look at that one, I can also say this is the same as A minus. I'll distribute the complement, that will become B complement. The sign changes to union, and then this complement also will go on here. There will be two complements, and two complements, they'll cancel each other, so that will just remain as C. And then this minus, I can also write it as A intersect. That will be B complement union C. The complement is going to come outside here. Why? Because we've changed the minus into intersection, and so there'll be a minus, a complement that comes there. And then we can distribute that complement, so that will be A intersection B complement will just be B, and then the sign changes into intersection, and then we're going to have C complement. So we've simplified in the simplest form, so we can now use this one. The first thing that I'm going to look at is B intersection C complement. So first looking at C, C starting from -5 up to 1. If we check in C, C includes -5, so it will not include, the complement will not include -5, so it will start from here. We'll go as far as where the universal set ends. The universal set ends at -10. And then we can see that C doesn't include 1, so the complement is going to include 1. And we're going to go as far as where the universal set is, that is at 10. In the universal set, of course, we're not including 10. So this is C complement. And then I'm going to put B. The set B is where? From 0 to 7. And we're including both 0 and 7. So where is B intersecting with C complement? So the common region is just here. So I'm now going to bring this on the same set or number line, 1 to 7. See, 1 and 7 will both be included because they are found in both sets, the set B and the set C complement. So this is B intersection C complement. Now we are going to get our set A and also put on a number line, that is from -3 up to 2. And we are not including -3, but we are including 2. Again, we are looking for the intersection of B intersection C complement and A. So where are those two sets intersecting? Is just from here up to here. And then we can now write a final answer. Therefore, A minus B minus C complement is just from 1 up to 2. That's the intersection. We are going to include both because we can see that they are found in both sets 1 and 2. So that is going to be it for this question. Okay, let's look at this one. Given that A and B are sets, express A intersection A complement intersection B complement in the simplest form. So first we distribute this complement, that will be A complement, the sign changes into union, and then we're going to have A complement intersection B complement, and then we're going to have also a complement outside because we've distributed this complement to both A and this part. So the sign changes because of De Morgan's law, that is what it tells us. And then this will be A complement union. I'll distribute this complement to what is inside. So that will be A complement which is just A. Then the sign changes into union. And then B complement which is just B. And then I'll distribute this A complement union with A. So that will be A complement union A. And then I'll again distribute this one with B. So I'll first get this sign which is on the mid, and then distribute this with B. That will be A complement union B. So A complement union A is the universal set. If you combine what is outside A and what is in A, that will give you the universal set. And then union A complement union B. Now whenever you get the union of any set with the universal set, that will just give you the universal set. So that is it for this one. But the intersection of any set with the universal set is that same set. The sets A, B, C all intersect and U is the universal set. Shade the part described by the region B union A complement intersection C complement, and then I've got a complement outside. So what I'll do is I'm going to distribute this complement which is outside, that will be B complement, the sign changes into intersection. Then we're going to have A complement intersection C complement, and then also a complement outside. So this will be B complement intersection. I'll again distribute this complement to what is inside. That will be A complement which is just A, and then the sign changes into union. C complement which is just C. Now we can shade this since this is the simplest we can go. So I've got the three sets and they all intersect. So the first thing that we are looking at is A union C. If you talk of A union C, just get A and C, combine everything. This is set A, combine with the set C, like that. Now, we also should B complement. What is outside B? So in other words, this is A union C, but where does it meet with the portion that is outside B? That's the meaning. Intersection. Where is it going to intersect with the part that is outside B? So the part that is outside B is, just remove this set B, but anything that is in the set A union C, but remove this set B. So that's the meaning of the question. Therefore, the region that is a B complement but A union C is going to be this region. Just remove the set B. Alright, so that is going to be it. Let's consider this one. Given that the sets A, which is from -7 to 3, B and C, and let R be the inverse set. So the inverse set here is the set of all real numbers. Find each of the following: A minus B. So when you're talking of A minus B is the same as A intersection B complement. So to be able to find this one, let's get a set A from -7 up to 3. And then B complement, since B is including -3 and also not including 3, so B itself is like this. So B complement will include the 3, and then it will not include -3 because -3 is already in B. So I'm just going to show an arrow like that because the inverse set doesn't end. It's a set of all real numbers. So this is B complement. Now where is A and B complement intersecting? So we can see they are meeting from here up to here. The question is saying and represent them on a number line. So this shaded region, and also you can see that 3 is both in A and in B complement. So also 3 is part of the set. So I can just write that on a same number line. -7 to -3. -7 is going to be part of the intersection, but -3 won't be part because it's not in B complement. You can see this is open. And then now we're going to our 3. At 3, this is part of the intersection because it's appearing in both, and I'll just put a dot there because it's not a range. So this is going to be A minus B, this region of, remember the question is saying also represent on a number line. So we'll say A minus B is from -7 up to -3, and then together with 3. Now 3 is just an element, so you use curly brackets, it's not a range. So that is going to be it. And then A union B intersection C complement. The first thing I'm going to look at is B intersection C. So B itself is from -3 up to +3. We are including -3, but we are not including +3. And then C is from -1 up to 6. We are not including any of them. So where are these two sets intersecting? It's here. I'm going to put that on the same number line from -1 up to 3. We see -1 is not part of C, so it will not be part of the intersection. And then 3 is also not part of B, so it will not be part of the intersection. So this is B intersection C. But we are interested in B intersection C complement, so we look for the region that is outside. So it will start from here. I'm going to include +3 because it's not part of what? It's not part of the intersection. Going in this direction, just put an R. And then also here we're going to include -1 because it's not part of the intersection. Going in this direction, put an R. If the inverse set was restricted, we would have just ended where the inverse set ends. But this is a set of all real numbers. It doesn't end. So this is going to be B intersection C complement. Now we are going to get the set A. Where is the set A? So here now I can even remove this because it's not part of our interest. So the set A is starting from -7 up to +3, and we're including both. Okay, like that. Now we want to take the union of B intersection C complement with the set A. So the final answer, if we union is just combining, so combine all these sets. So we see if we combine it will just continue, like it will be a set of all your numbers. So to show on a number line, it will just be like this. It will include all numbers because we can see the arrow will continue going like that, and the arrow is continuing to go like that. So therefore A union B intersection C complement is a set of all real numbers from negative infinity to positive infinity. Well, for infinity you should never use these brackets because we don't know the exact number what infinity is, so that's why you don't include, you always use open brackets. Let's consider this one. Let x be from 1 to 10 be the universal set. And then, actually this wasn't from 1 to 10. It was supposed to be from 10, negative 10 to 10. The reason is very simple. Let me just get to show it. So the first thing is we want to find B complement. How do we find B complement? Let's put that on a number line. Remember, the first thing that you put on your number line is the universal set. So if the universal set is starting from 1 up to 10, now let's put B. We can see that B is starting from 2 up to 8. There is no set that should have elements that are outside the universal set. We can see 2 is not part of the universal set. How can it be part of B? So it's not possible. Even if you can see that it's an open bracket, like you can see, no, we are not including 2. What of, there are numbers which are less than 2, but they are part of the set B. They are not part of the universal set. For example, 1.5. 1.5 is part of the set B, but it's not part of the universal set. That's not possible. So that's why we need to change the universal set. So I'll put it as from negative 10 up to positive 10, like that. So this, take it as negative 10 up to positive 10. Now we are going to get the set B that is starting from 2 up to 8. So if you see the set B is not including 2 and 8, therefore B complement is going to include both of these sets. And you can see the universal set is including both negative 10 and positive 10. So we are going to shade like that. Therefore B complement is going to be from negative 10 to 2, and then from 8 to 10. Okay, and display them on a number line. So we've also displayed on a number line. And now I want to look at A intersection B minus C. So A intersection B minus C is B intersection C complement. So the first thing that I'm going to look at is C complement. First put the universal set, negative 10 up to positive 10. So if you check, the C is including 3 but not including 6. So C complement is going to include the 6, but it will not include the 3 because the 3 is already in what? In C. And then I'll look at B. B is starting from 2 up to 8, and we're not including any of them. Okay, now our interest is to find out where is B intersecting with C complement. So you can see it's just between these two, 6 and 8. But 6 is going to be part of the intersection, and then 8 is not going to be part. Why? Because 8 is not part of this set. Alright, so it is going to be like that. This is B intersection C complement. Now we're going to get the set A. The set A starting from 1 up to 4, and we're including both 1 and 4. Now, are these two sets intersecting? Because we're looking for the intersection of A and B intersections. Are they intersecting? No. So therefore A intersection B minus C is going to be an empty set. They are not intersecting. So when you want to show an empty set on a number line, just write a number line without anything, because the question is saying and show on a number line, so there is no intersection, so that will just be an empty set. And then we want A intersection B. So the set A is from 1 up to 4, including both 1 and 4. And then the set B is from 2 up to 8. We are not including n. So the intersection is from here up to here. Therefore, A intersection B is going to be from 2 up to 4. 4 is both in A and B to be included, but 2 is not in B, so it will not be part of the intersection. Okay, so that is how it's going to be. And the last one we have here, the sets A, B, and C all intersect and use the inverse set. Shade the part described by the set B union C minus A intersection B. They've said the sets, they are all intersecting. So first I'm going to show we have got a set A, set B, and the set C. They are all intersecting like that. So the first thing is we need to simplify what has been given, B union C minus A intersection B. So this also means that B union C, and then I can change this into intersection, and then that will be intersection B. Because of changing it to intersection, there will be a complement that comes here. It all comes from this. A minus B means A intersection B complement. So whatsoever the second thing which is here, you put a complement there when you change a minus into intersection. I can now distribute that complement. So that is going to give us B union C, and then intersection, so that will become A complement union B complement, like that. At the same time, it wouldn't be even that necessary even to reach up to this stage. I can just work it out just on the stage that is on top. So the first thing that I'm going to do is to shade B union C. I'll put that in red. So this is B union C, and then I'll look at A intersection B complement. So where is A intersection B? A intersection B is this region. Now we want what is outside this blue region. So I'm going to shade everything outside that blue region, outside the intersection of A and B. Now we are looking for where the blue lines are intersecting with the red lines. Which region is that? So we can see that. You can put that on a different one now, which will be the final one. Therefore, the region of interest, we can see where those lines are intersecting. First, we have got this part of B, they are intersecting there. Okay, like that. And then we also have the set C, they're also intersecting in that region. And then we also have this also region here, they're also intersecting. So this is going to be it. You shade just everything but remove the intersection. You are going to shade B and C but remove where A and B are intersecting. So that is going to be it, and that is it for this one.